This lesson is on probability, with the first lesson, this topic being on probability trees. So, we use probability trees to show all the different outcomes of a little mathematical game or an activity that someone might be doing, to see all the probability of all the possible outcomes of the game. Okay, so here we've got an example here. There is a bag with red and green balls in it. After you pick a ball, you then put it straight back in the bag, and then you pick out another ball. Okay, so you're going to be taking a ball out of a bag twice. Okay, the chance of picking a red ball out of the bag is 0.3, and the chance of picking a green ball is 0.7. So we're asked to complete the probability tree and then find P green red. Okay, so we're going to talk about what this means in a bit. Okay, but first of all, let's complete the probability tree. So let's have a look at this first branch. Okay, so starting on the left here, we can see we've got two branches, and these branches represent the two different outcomes for the first choice. Okay, for the first event. The first event here is we pick a ball out of a bag, and the chance is it's either red or it's green. And we're told the chance of picking out a red ball is 0.3. And we can see here the arm going to red says 0.3. And the chance of picking a green ball is 0.7. Therefore, the arm going to the green ball, that should be a probability 0.7. Okay. Now, let's go along the top arm here first. And we get to another event. And this is after we've put the ball back in the bag, we've picked out a second ball. Okay. Now, we can either get a red ball. Remember, the chance of picking a red ball is 0.3, so the probability of that will be 0.3. And the chance of picking a green ball as the second ball will still be 0.7, okay? Because remember, we put the ball back and then we picked out a second one, okay? So we're happy with green being 0.7 again. If we then go back to the start and imagine that we picked a green ball first, okay? And now we've still, for the next event, we've still got two options. We can either pick a red ball or a green ball. And because we put the ball back after we picked it, it's the same number of balls in the bag. So the chance of picking a red ball would still be 0.3, and the chance of picking a green ball would still be 0.7. Okay, so there you go. We've completed the tree. We've completed the probability tree. Okay, now part B says to find P of green red. Okay, so P of green red, and all this means is the probability of green then red. Okay, it's just a statistical notation for writing the probability of finding a series of events. Okay, so P green then red is the probability of finding green then red. Okay, so we're looking for one of these outcomes that shows that we picked a green ball and then we picked a red ball. Okay, so if we follow the tree, we pick a red ball, then a red ball. That would be P R R. If we picked a red ball first of all, then a green ball, that would be P R then G, red then green. If we picked a green ball first, and then we picked a red one, that would be probability of G then R. And if we picked a green ball first and then another green ball, that would be probability of green then green. So we're trying to find probability of green then red. So we're looking for this one here, probability GR, probability green red. Okay. So how do we then? What's our final answer for this question? Well, when we go across a probability tree, when we go from left to right, as we look at the probabilities of the events, in this case it's 0.7 and 0.3, we need to multiply them together to find the probability of both of them happening. Okay, so probability of green red is equal to 0.7, which is the probability of a green ball, multiplied by 0.3, which is the probability of a red ball. And if you do 0.7 times 0.3, you should get 0.21. Okay, so the probability of green-red is 0.21. Okay, let's have a look at another example. So we've got another bag now, but with purple and yellow balls in it this time, okay? After we pick a ball and we look at the color, we then put it back in the bag, and we're going to do this twice, okay? We're going to pick out a ball, look at it, put it back, and then pick out another one. The chance of picking a purple ball is 0.1. Chance of picking a yellow ball is 0.9. First of all, we need to complete the probability tree. And then secondly, we need to find the probability of purple then yellow. And then we need to find the probability of one yellow ball, okay? So let's complete this tree first. So if the chance of picking a purple ball is 0.1, if we then picked a second purple ball, because we put it back, the chance of that purple ball would be still 0.1. If we go back to the start, the chance of picking a yellow ball, we're told is 0.9, so 0.9. And then again, we're missing the chance of picking this yellow ball. Because we put it back, it would still be 0.9. Okay, so we've completed our tree. Lovely. Now, we're trying to find the probability of purple yellow. Okay, so remember, probability of purple yellow is the probability of purple then yellow, okay? Purple then yellow. And that, if we're looking for these outcomes, that is just going to be P of Py. Okay, so that's the outcome we're looking for here. Okay, so which of these branches is purple and then yellow? We'll just start off with, we pick purple, and then we pick yellow. Okay, so this is the probability of purple then yellow. The chance of getting purple in the first event was 0.1. The chance of getting yellow in the second event was 0.9, so we need to multiply those together. 0.1 times 0.9 equals 0.09. Okay, so we found that. Well done, us. So that's the first one done. And then the second part now, we need to find the probability of one yellow ball. Okay, so probability of one yellow ball. Now we need to imagine all the outcomes where we pick only one yellow ball. Okay, so we have to do both events, but after we've picked a ball out 2 times, we only have one yellow ball. Okay, now there's two outcomes where we can get that, and that's either the first outcome where we pick a purple ball first and then a yellow, and the second one is the probability of picking a yellow ball first and then a purple one. Sorry, not a red one, purple one. Okay, so both of the outcomes, we only pick one yellow ball, okay? The other outcomes, 2 yellow, doesn't count because that's 2 yellows. And the other option, 2 purples, doesn't count because there's no yellows, okay? So to find the probability of at least one yellow ball, we need to add these 2 outcomes together, okay? Well, we found the probability of purple and yellow. That was 0.09. What's the probability of yellow then purple? Well, let's have a look. So if we follow the tree again, get rid of those lines. So we're going to pick yellow first, which is a probability of 0.9. And the probability of purple is 0.1, okay? So probability of yellow then purple equals the probability of yellow was 0.9. Probability of purple was 0.1. So we've actually got the same question here, okay? 0.1 times 0.9 is the same as 0.9 times 0.1. So that's going to be 0.09. So we're looking to add 0.09 plus 0.09 together. That is equal to 0.18. Okay, so that's the probability of one yellow ball. Okay, so done the second one there now, okay? So what you might have noticed there is when we go across the probability tree from left to right, we multiply the event probabilities together. But when we're finding the probability of multiple outcomes, we add them together. So if you're going across the tree, you multiply. If you're going down the tree, you add the probabilities together, okay? So let's have a look at one last example now. So Johnny plays 2 different carnival games in a row. In the first game, he has a quarter chance of winning a prize. In the second game, he has a 2/3 chance of winning a prize. Complete the probability tree. Find P that he wins the first game, loses the second, and find P that he wins at least one prize, okay? So first, let's complete the tree. So we're told the chance of him winning the first game is a quarter. Now, all probabilities, all lengths have to add up to 1, okay? Because there has to be an outcome. Either he wins or he loses, okay? So we need so if we know there's a quarter chance of him winning, we need to think, what is the chance of him losing? It has to add to it. So something plus a quarter equals 1. Well, it's going to be 3/4. So the chance of him losing the first game is 3/4. That way, a quarter plus 3/4 equals 1. And all probability outcomes have to equal 1 because it shows that there is an outcome. There has to be an outcome, okay? And then for the second game now, so this was the first game, sorry. If we then look at the second game, we're told that he has a 2/3 chance of winning a prize. Therefore, if he's got a 2/3 chance of winning, that must mean he has a 1/3 chance of losing, because 2/3 plus a third equals 1. That means there has to be an outcome for this event, okay? So we've got 1 lose there, and then we also need to put a third down here for the other lose branch, okay? Cool. Probability tree completed. Now we need to find the probability that he wins the first game and loses the second, okay? So let's draw along the tree. He wins his first game, and then he loses his second, okay? So now here we've got probability of win, lose. So now we need to multiply these two probabilities together. So we've got the probability that he won the first game was a quarter. Multiply that by the probability he won the second, that he lost the second game, sorry, was a third. To multiply fractions, you multiply the top. So 1 times 1 is 1. Then you multiply the bottom. 4 times 3 is 12. So the probability that he wins the first and loses the second game is 1/12. Okay, job done. Now the second question, or third question, part C, sorry. Find the probability that he wins at least one prize, okay? So we're trying to find P wins at least one prize, okay? Now the at least part here is really important, okay? So that means he doesn't only have to win one prize. It means he could win 2 prizes because he's at least won one prize there, okay? So what we're looking for is P. Well, what are the outcomes where he could win at least one prize? Well, he could either win both of them, so PWW. He could either win the first one, then lose the second, so PWL, win then lose. And he could also lose the first one, but then win the second one, so PLW. Okay, so there's 3 different outcomes here where he wins at least one prize, okay? So now we need to find the probability of those outcomes, okay? So we're looking to find the probability of win-win and the probability of lose-win. Okay? And if you run all the numbers, so probability of win-win, the chance of him winning the first game is a quarter, and the chance of him winning the second game is 2/3. Multiply the fractions. 1 times 2 is 2. 4 times 3 is 12. We're going to leave this as over 12 for now, and I'll show you why at the end. Then the final one, probability of a lose then a win, is a 3/4 chance that he loses, and there's a 2/3 chance that he wins. Multiply them together. 3 times 2 is 6. 4 times 3 is 12. Okay? Now, find the probability that he wins at least one prize. We need to add all of these probabilities together, okay? So let's add all these probabilities up, okay? So let's remind ourselves it's probability of win-win, which was 2/12. We're going to add that to probability of win-lose, which is 1/12. We're going to add that to probability of lose-win. which was 6/12. Okay, now hopefully you can see why we kept them as over 12, because now this part is much easier. Okay, it's much easier to add these if they've all got the same denominator. Okay, so because they've all got 12 as their denominator, that means it's going to be over 12. And we just add the numerators. 2 plus 1 plus 6 equals 9. Now you can feel free to simplify this, okay? So P wins at least one game equals 9/12. And you can simplify this now, please do. I'm going to divide them both by 3. So that gives me 3/4. Okay, so equals 3/4. Okay, so those are my final answers for these questions. Okay, probability wins the first, loses the second is 1/12. And the probability that he wins at least one prize is 3/4. Okay, so very well done if you got those. Okay, or if you figured that out yourself. Okay, let's have a look at the main task now. So these questions take up quite a lot of space. Okay, so these are the first two questions. Okay, so pause the video and have a go at these. Okay, feel free to draw out. Well, you need to draw the tables out on a bit of paper. Okay, the probability trees on a bit of paper. Okay, so you can find the missing probabilities. Okay, and then you need to find there's two outcomes you need to find the probability of. Okay, so pause the video and have a go at these. Okay, here are the answers. Feel free to pause the video to double check that you got it right. I've sort of scribbled over as much as I can. So here's the second round now, second round of questions. So again, pause the video, make sure you read the questions, draw the probability trees, and answer the questions. Okay, best of luck. And here are the answers. Very well done if you got those right, and a big well done if you use the correct notation of P and then whatever you're trying to find the probability of it inside the brackets. Okay, using letters to signify pass, fail, rain, late, on time, whatever. Okay, so well done. And here comes the checking question. Okay, so we're on the checking question now. George has a bag with 4 white counters and 6 red counters. He picks out a counter, records its colour, and without placing it back in the bag, he selects another counter. Complete the probability tree and find the probability that he picks 2 counters of the same colour, okay? Now double read the question again, because there's a really important part that I've actually highlighted and underlined. And that makes this question slightly different to the others you've done so far this lesson, okay? So pause the video and I'll go. Okay, so let's have a think of the answer now. Okay, so first of all, let's think about what are the probabilities of the outcomes for the first counter that he picks. Okay, so we're told that there are 4 white counters and 6 red counters in the bag. Okay, so that means there are 10 counters in total. So both of these outcomes will be out of 10. Okay, because there's only 10 counters in there. There's only 6 red counters in this bag, so the chance of him picking a red counter is 6 out of 10. And there's only 4 white counters, so the chance of him picking a white counter for the first one is 4. Okay, easy enough. Now, the key part of this question was that he picked a counter and he did not place it back in the bag. Okay, so let's think about this. If we had 10 counters and he has taken one out, how many counters are going to be left? Well, there's only going to be 9 left. So all of these outcomes that follow can only be out of 9 because we've taken one marble out. Okay, so if we follow the first branch, say we picked a red marble first of all. Initially there were 6 counters, sorry. If we've taken one out, that means there's only 5 red counters left in the bag. So the chance of picking a red counter the second time has to be 5/9, 5 out of 9, because there's only 5 red counters. There's only 9 counters in the bag. Now for white counters, we've taken one counter out, but it was a red one. So the number of the white counters will still be the same, okay? So there are still 4 white counters in the bag. Okay. Now let's imagine we picked a white counter first of all, okay? So because we've taken a counter and we put it back, there's only 9 counters left in the bag, so that's fine. But if we've taken one white counter out, all the red counters are still in there. So that means there's still 6 red counters in there. But if we think about picking a white for the second time, well, there's going to be one less white counter because we've taken it out the first time we chose a counter. So there's going to be one less than 4. So it's going to be 3, okay? So well done if you got this far for completing the probability tree, okay? Now, that's the final part of the question, which was to find P of 2 of the same color counters. Okay, so we're trying to find the probability that the 2 counters he picks are the same colors, okay? So if we quickly just run through all these outcomes. So the first one, probability of red, then red. Then the second one, he picks red, then white. This one, he picks probability white, then red. This one, probability of white, then white. Okay, so hopefully it should be fairly easy to spot now which is the 2 of the same color options. It's when he picks red, then red, and when he picks white, then white. Okay, so let's figure out what these are. So P, I'll tell you what, we'll do this down below. So P of red and red. Well, the first outcome was the chance of him picking red then red. He had to have a red counter first, which was 6 out of 10. Then he had to have a red counter second, which is 5 over 9. Multiply them together. 6 times 5 is 30. 10 times 9 is 90. There we go, 30 over 90. We're not going to simplify just yet, and you'll see why now. Next, we're trying to find the probability of white and white. So first chance of him picking a white counter first of all is 4 out of 10. The chance of him picking a white counter the second time is 3 out of 10. Okay, so 4 times 3 is 12. 10, not over 10, should be over 9, sorry. Over 9. 4 times 3 is 12. 10 times 9 is 90. Okay, so to answer our final question, P, let's make that simpler. P, same color. So find the probability he picks the 2 that are the same color. That's going to be P, R and R plus P, not R, W, W. And we know now probability of red then red is 30 over 90. Probability of white and white is 12 over 90. 30 plus 12 is 42. And it's going to be over 90 because it's the same denominator. Now we need to divide these, simplify the fraction. What's the highest common factor of these? Well, I think it's going to be 3. You can divide 42, might be bigger than 3 actually. It's going to be 6, sorry. 42 divided by 6 is 7. And 90 divided by 6 is 15. Okay, so the probability of picking 2 marbles the same color is 7 over 15. Okay, let's just highlight that for you. So very well done if you got that question right. Okay, there's lots of little steps, and this part where we don't replace the counters. Okay, this is going to be this is where they try and trick you up in the exam. Okay, so very well done if you got that right, and I'll see you next lesson. Bye now.